Many natural phenomena follow the law that an amount A varies with time t according to the function a of t equals a sub naught e raised to the kt, where a sub naught, the number in front of e, is the initial amount. If k is greater than 0, then we call it a growth equation. If k is less than 0, we call it a decay equation. Here we have strontium-90 being a radioactive material that decays according to the function a of t equals 500e raised to the negative 0.0244 t, where t is in years and the strontium, the material, is measured in grams. So what is the initial amount of strontium-90? Well, if you're not sure, we know that the initial amount should always be at t equals 0. So we're going to have a of 0 equaling 500 e to the negative 0.0244 times 0. But like I said before, the number in front of e is your initial amount right here. So this should equal 500 grams. But don't take my word for it. Let's let a calculator tell us. So 500 second ln of negative 0.0244 times 0, and that'll give us 500, so pretty nice, confirms it. Now, what is the decay rate? The decay rate is k, and k is the number that's next to t in the exponent, in this case, negative 0.0244. But I don't want this, I want the decay rate. So I multiply this by 100 to get the percentage, which will be negative 2.44. Now, how much strontium-90 remains after 10 years? Well, we have our time, which is 10, so t is 10, so I'll just plug in 10 for t. So I'm going to have a of 10 equaling 500 e to the negative 0.0244 times 10. Now, unlike the first one, I don't know what this is off the top of my head, so I just let my calculator do the work. So 500 second ln negative 0.0244 times 10. And it tells me that there are 391.7 grams. So 391.7 grams after 10 years. Now, when will there be 400 grams? Well, I need to know the time, t, so 400 must represent, and it does, the amount. So I'm going to set 400 equal to my function. So 400 equals 500 e to the negative 0.0244 t. Now solve for t. I will divide 500 over and simplify, so that'll be 4/5 equals e to the negative 0.0244 t. Take the natural log of both sides. ln of 4/5 equals negative 0.0244 t. Again, L and E just cancels out. And now I'm going to divide both sides by negative 0.0244. So I'm going to have ln of 4/5 divided by, I have to write it down here. It's okay, negative 0.0244. And that's going to be t. Now I just plug this whole thing into a calculator so I know what the number is. So I'm going to have ln of 4/5 divided by negative 0.0244. And that'll give me 9.1. So 9.1. And remember that time here is measured in years. So our time here of 9.1 is going to be 9.1 years. Now, what is the half-life of strontium-90? Half-life is the time it takes for half of it to go away. So we know from part A that we have initially 500 grams. So after so much time, we'll only have half of it. So we will have 250. So our A value is 250, so I'll set my equation equal to 250. So 250 equals 500 e to the negative 0.0244 t. And now I'll divide both sides by 500. And no surprise, I get 1/2 because it's the half-life. E to the negative 0.0244 t. Take the natural log of both sides. I'm going to get ln of 1/2 equals negative 0.0244 t. Again, ln e just cancels. And divide both sides by negative 0.0244. So ln of 1/2 over negative 0.0244, which is t, but I need an amount, so I'm going to plug it into my calculator, which I will get ln of 1/2 divided by negative 0.0244. And I will get 28.4, so 28.4 years for it to decay to half of its original amount. Now there is a formula for half-life if you don't want to go through this whole process. The half-life formula is ln of 1/2 divided by k. So if you'd rather memorize that, you are more than welcome to. It will be the exact same answer.